Okay, hello, welcome to our webinar here at APEC on strength and power development. Today myself, Alex Porter, I'm one of the tutors here, and Craig Bolger, one of the other tutors here, are going to talk around strength and power development. This is going to be a bit of a continuation on from our Instagram live we did last Wednesday, delving into this topic. So we're going to present in a bit more detail today and just add in a bit more around the topic. Today we also have Mihal, who's in charge of our social media. He's going to be running and recording the session so that we can stick it up on our blog after. If you have any questions, or if there's any comments you want to make, or if there's something you want us to go over again throughout the presentation, just stick it into the comments section and we'll come around to it at the end. Okay guys, so to get started today, I'm just going to give you a quick run through of what the content is going to be. So we'll have our introduction, then we're going to get straight in and we're going to work on defining the strength and power first so that we have a good base on the content we're going through. Then we're going to talk about different expressions of strength. So I'm going to use the force velocity curve to talk through this. Then we'll have different factors to consider when designing our sessions, determinants of strength and power, training adaptations, session design. Then we're going to bring you through a sample strength session and then through a sample power session. And we'll finish with some key take-home points, and then we'll have our question session at the end. But first off, when we get into it, we're going to first off define our two variables here. So strength. Strength and power are two connected but separate concepts. It is important to understand the difference between the two. Strength is the ability to exert force. This covers three types of muscle contractions: our eccentric contraction, our concentric, and our isometric. When we think of strength, we often think of specific lifts. In practice, however, strength can be expressed in a multitude of different ways. A scrum in rugby, for example, players are exerting maximal force, which requires a lot of strength, but it's an isometric contraction and there won't be much movement between the players. So strength is our maximum ability to exert force. This can through our three different types of muscle contractions. So sometimes all three can be used. So in something like a squat, when we have our concentric, our isometric hold at the bottom, and then our eccentric as well. Whereas then sometimes it could just be a singular one of these, such as our isometric. Then moving on, we're going to define power. So power is a more technical physics concept to understand when used in relation to strength training. The definition of power is as follows. Power is equal to work divided by time. So then we just need to know what our work is. So our work is just our force multiplied by displacement. So when we had force already, it was in strength. So the maximum amount of force we can produce is our strength. Displacement is quite simply how far something moves. So this could be from in a deadlift, from the bar moving to the floor up to a hip level. So this is the amount of work we're doing and the displacement. So then we go to power, can be described as force multiplied by displacement divided by time. So our force is the amount of strength we're using, the displacement is the distance that's the object or the bar is going to travel, and then this is all divided by the time it takes us to do it. Power is used as a measure of ability to exert force at higher speeds. In the field, power is often loosely described as explosive strength. This is a particularly important concept in relation to training athletes. Examples will be kicking a ball, throwing an object, jumping, and sprinting. So when we think of power, we're thinking about higher speeds, so things like our Olympic lifts, our jumping, and our sprinting. These will all be high power movements. So how do these look in practice? So on our left here, we have a deadlift. So if we imagine this is a deadlift in like a strongman competition, the weight is going to be very heavy and it's going to be near our max strength, but it's going to be a very slow movement and it's going to require a high level of force from us to pick this up off the floor. Then if we look on the right, we have someone performing some weightlifting, some Olympic lifting that's currently going on in the Olympics. So here the bar is going to move faster and there's going to be a larger displacement in these movements as well, which is moving further. So then one area that is often confusing for people is the term powerlifting. So this is our deadlift, bench, and squat. These require actually quite a low component of power and a lot more strength because it's all slower movements, but it requires a lot of force to move the bar in these ones. Then we're going to go into the force velocity curve now quickly to describe how these movements occur. First off, on our force velocity curve, We've got our force on the y-axis. So this starts from low force all the way up to high force. And then on our x-axis, we have velocity. So over towards the left in the corner, this is slower speed. And then as we move more towards the right, this is going to be a higher speed. So our max strength is going to be a low speed movement, but require a lot of force. So this is where our deadlift, our bench, our squat, our slower movements are. And then as we move along the curve, we have our strength speed and our speed strength. So these require slightly less force, as we can see, because the curve is dipping down. But as the curve moves to the right, further along the velocity, it requires more speed during the movement. Further along the curve then, we have our reactive strength, and then we have our outright speed. These two components we can see require less force again, but they're also faster movements because they're further along the velocity side. So this is going to be an important concept, so I'm going to leave this up here for a minute because we're going to cover this later again in our power training. So the more force at the start is our max strength as the amount of force required, but the speed goes up, we move further along the curve down into our strength speed and our speed strength, which would consist of our Olympic style lifting. Then we have our reactive strength and our outright speed, which would be sprinting. Here we have some exercises across the curve. So at the start in our max strength, we have our bench press, squat, deadlift. Then we have our squat clean and our snatch. As we move further down, they're getting faster movements. So we've got our power clean and our power snatch. Then we've got our jumping exercises. And finally, we've got sprinting at the bottom.
Okay, so if we look at the determinants of strength and power expression, so that's just what factors affect strength and power expression. We can really break these down into two main factors. So that would be like morphological factors and neurological factors. So morphological factors would include stuff like muscle size, so the size of the muscle architecture, which is mainly looking at angle of pronation. So we'll get into each of these a bit more in detail, so don't worry too much for now. Then you'd have muscle composition, so the ratio of type 1 to type 2 fibers. And then you'd also have like tendon stiffness and compliance. And then looking at some of the neurological factors that can contribute to force production and peak power would be agonist activation, antagonist co-activation, and what's called afferent feedback. Okay, so looking at each of these in detail, a bit more detail. If we so if we first look at the morphological factors, so the first one to consider would be muscle size. So the relationship between force production and muscle size mainly comes down to the amount of cross bridges in parallel with one another. So remember, with cross bridges, we're looking at the myofilaments actin and myosin and how much of them are side by side. So this is where your understanding of anatomy and physiology really comes into play. Okay. So if you think of, so if you have like one cross bridge, looking at this image here on the right, we can produce 1 unit of force. Where if you have 2 of these side by side or in parallel, you can produce double the force or 2 units of force and so forth. The more of these we have in parallel with one another, the more force we can produce. Okay, so the next one to consider would be, moving on there, would be muscle architecture. Looking at muscle architecture, what we're looking at here is essentially the angle of pronation. So the angle of pronation is the angle between the 2 tendons and then the muscle fibers. So looking at this image here on the right of a muscle, you have the 2 tendons or the origin insertion on the left, and then in black you have the muscle fibers, and then the angle of pronation is the angle between these. Okay, so the angle of pronation, so the greater the angle of pronation, the more muscle fibers or even myofilaments that we can have arranged in parallel with one another. So then thinking back again to muscle size, the more muscle myofilaments or cross bridges we have in parallel with one another, the more force we can generate. Okay, so what you generally find is the optimal angle of pronation is about 45 degrees. Any more than 45 degrees and you don't get force production you're not generating force in the right plane. So if you look at this image here, If the angle is greater than 45 degrees, then you don't have the origin and insertion moving closer together. What you'll see is they'll end up almost like moving up and down or side to side, and you're not generating force in the correct direction. Okay, so that's muscle architecture would be the next one to consider. If you just move on there, Alex. So then the next two morphological factors to consider would be fiber type or fiber. So this would be where we're looking at the percent of type 1 to type 2 fibers. So with this, the greater or the faster the speed of contraction, the more force we can generate, okay? So this speed of contraction comes down to the cross-bridge cycling. So once again, how them actin and myosin filaments interact with each other. And the rate of this cross-bridge cycling depends on the concentration of an enzyme or a protein called ATPase. And essentially what this does is it catalyzes or it speeds up the breakdown of ATP into ADP and PI, okay? So I know we're getting quite sciencey here, but what this means is if you look at this image down here, this first reaction or in the sliding filament theory, or how like the actin and myosin interact, it speeds up this reaction. So the higher the concentration, the faster this can cross-bridge cycling is between that, and it means we can generate more force, okay? And typically what you find is type 2 muscle fibers have a greater concentration of this protein ATPase. And then finally moving on to tendon stiffness and compliance. So tendons have a very good viscoelastic property. So this means that they can store and utilize energy when the tendon is put on stretch. And so what you find is tendons can be either a little bit stiffer or a bit more compliant. So a stiff tendon can absorb energy and then use that energy very quickly. So it can transfer that energy very quickly. So if you look at this image down here, if you have like a very stiff tendon, so it would be like pulling on a box with a stick. So as soon as you pull on the stick, the box moves. Whereas if you have a very compliant tendon or a very elastic tendon, as you pull on that box, it'd be like an elastic band strapped to that box. The elastic band will stretch to a certain extent, and eventually it'll reach a point where it then pulls the box forward very fast, okay? What we generally find though is stiffer tendons are better. So they're better for creating large forces very quickly. So you'll see an increase in rate of force development, and then this carries over to better sprint for performance, which is a huge part of like performance for athletes and runners and that. So just moving on. So then the next, I suppose, the next main factors that can affect it would be neurological factors. So just a quick run through of like the neuromuscular pathway, okay? So you have to remember that all voluntary movement starts from the motor cortex, or starts from the brain, and then from there we get a signal or an action potential sent down to the muscle, telling it to contract and generate force, okay? But on top of this, we also have what's called an afferent feedback, and essentially what afferent feedback is, you have little sensory neurons within the muscle, and they send signals from the muscle to the brain to tell it that it needs to generate more force, or it needs to stop generating force, okay? So you constantly have this like cycling of a signal coming from the brain to the muscle, and then a signal going back from the muscle to the brain. So moving on. So if we is that gonna, okay, good. So looking at some of these neurological factors that affect force production, so the main ones we'd look at would be agonist activation and antagonist co-activation. So agonist activation, if you think of like a leg extension, would be the activation of like the quadriceps muscles, okay? And the extent of activation is mainly determined by two factors. So this would be recruitment and firing frequency. So recruitment refers to what's known as the Henneman size principle. And essentially this is where the smaller type 1 fibers are recruited first. So for like exercise or movements that only require a low amount of force generation, it's like picking up your phone or like picking up a pen, And then as the higher force is required, so as you start to increase the weight, then you begin to recruit them faster type 2 muscle fibers, okay? And then firing frequency just refers to the speed of the action potentials, or the speed of these signals being sent from the motor cortex down to the working muscle to tell it to contract, okay? So once again, if you think of, if you're only sending like one signal like each second, it's that there's going to be like a long pause in between contractions, whereas the faster you send these signals down, all of a sudden you get what's called like a summation of action potentials or signals. So it's like where they nearly all like join together, and then you're able to generate more force, okay? And then finally we have antagonist coactivation. So this is actually a bad thing. We don't want antagonist coactivation. So if you think of leg extension again, as you're like as you're contracting your quads to try and lift the weight, if you have, in this instance, the antagonist muscles would be the hamstrings, and if they're activating, they're generating negative force, so they're pulling against the movement you're trying to perform, and therefore you're not able to produce as much or generate as much force in the correct plane, okay? And on top of that, we also get something what's called reciprocal inhibition. So when the antagonist muscle, in this instance the hamstrings, are contracting, there's a signal sent down from the brain to stop you contracting the quadriceps, okay? So what we want to try and do with training is reduce antagonist coactivation. And then finally, for the neurological factors, we have what's called afferent feedback. So we covered this earlier. So these are like little sensory neurons that sends information in the muscle and then send it back up to the brain, okay? And this can be broken down into two main categories. So we'd have muscle spindles and then the Golgi tendon organ, or the GTO. So muscle spindles, they react to changes in muscle length. So think about when you're picking up a weight or performing some sort of activity, the muscle lengthens, and this change in length sends a signal to the brain telling it, okay, there's a change in length, we need to produce more force so we can perform this movement, okay? The GTO, on the other hand, detects change in tension. So think about when you're trying to lift a really heavy object, okay, and you're not able to move it, or it's close to like your 1 RM, the GTO sends a signal to the brain being like, okay, we're producing too much force now, we could hurt ourselves, we need to stop this. So it's like an inhibitory effect. So this is something we don't want, because this can reduce force production. So then moving on to some of the training adaptations that occur with strength and power training. So once again, we're always thinking about what affects strength and power expression and then how these are changed. So on the left here, I just have it broke down into strength and power training, and then across the top we can see I have it broke down into neurological and morphological adaptations. So generally what you find with strength training is the first like kind of 10 to 12 weeks are going to be mainly neurological adaptations, and then it's only after like several weeks of training that you'll begin to see some morphological adaptations. So looking at some of the changes we see, you can see like following strength training, there will be an increase in agonist activation, and this is mainly due to firing frequency. So thinking about either like a bench press or that leg extension, what you see is after strength training, you're getting more like signals sent down to the muscle to like contract more and generate more force. And this is usually because an increase in firing frequency as opposed to recruitment, okay? What you also see is an increase in stabilizer muscle activation. So as you're performing the bench press, you might see an increase in like the activation of the shoulder muscles, so the delts. You'll also see a reduction in antagonist co-activation. So once again, for that leg extension example, there will be a reduction in hamstring activation, so you're not getting as much negative force production. And then finally, you'll also get a reduction in afferent feedback from the GTO. So following a period of strength training, your body is now after adapting to performing exercises with really heavy weights where they have to produce or generate a lot of force. So you're after training your body and your muscles to be like, okay, this is fine. we're not going to injure ourselves performing this exercise, so then we don't have to send signals back to the brain to tell us to stop this, okay? Then looking at some of the morphological adaptations, the main one would be an increase in muscle size, and this is primarily due to myofibrillar growth and proliferation. So once again, thinking back to myofibrils, they're made up of little myofilaments called the actin and myosin, and what you'll see is an increase in the amount of these in parallel with one another, like we covered earlier, and therefore the more like actin and myosin or cross bridges that are in parallel with one another, the more force we can generate. Also, you'll see an increase in angle of pronation. So most people's angle of pronation is quite far away from 45 degrees, so it'll usually only be about like 8 to 10 degrees. And what you'll see is following a period of strength training, this can increase to maybe 12 or 14 degrees, okay? Then moving on to power training adaptations. For the neurological adaptations, you see similar changes to that of strength training. And same with the morphological adaptations, okay? So you're not going to see huge changes in muscle size. There might be a little bit, but there's not that much. But what you do find is there's changes in muscle fiber type composition. So you'll get an increase in the percent of type 2 fibers. So you'll get type 1 fibers converting to like type 2 fibers. And what this means then, so when you're thinking back, with type 2 fibers, we have a greater concentration of that little protein, the ATP, as I mentioned earlier, and this helps with, so what this does is it helps with faster contractions, and therefore we can generate more force. One thing I want to make clear with power training is the main adaptation we're making here would be like neurological adaptations, and specifically neural activation at fast contractions, okay? So when you're performing these movements, you're trying to perform them as fast as possible. So what you're doing is you're increasing the rate that you can develop force at, okay? So you're making improvements to these fast explosive movements, okay? So then if we move on and just look at some session design considerations.
Yeah, so session design considerations. This is when we're actually sitting down. We know what the adaptation we're looking for is, now what some things we've got to consider before we start writing our program. The level of our athletes, so this is going to have an effect on what types of training they should be at. If we have a very untrained athlete, then they're going to have to build basic strength and endurance first before they can go into the more advanced power side of stuff. The person's training age and biological age, these are going to have an effect on how difficult the training is for them, how their body takes it, and how well they recover from these sessions. As well as this, we need to take into account previous injury and medical history. One of the biggest indications for injury is previous injury. So if someone has problems with knees or anything, or hips, these are the kind of things we need to consider before we go in and start loading somebody up quite heavily. We got to make sure that they're strong to this and they're able to adapt to this new demand, the demands of someone's sport or the goals of a client. So if they don't need to be doing a lot of power work, or they don't need a huge amount of strength work because they're already good at this, then there's no point in focusing on something that is so heavy on them and such a demanding process. And then in team sports particularly, we're looking at time of the season. So during, say, a field sports season like soccer, rugby, Gaelic football, you might not have much time to develop all these qualities. So the pre-season and sometimes the off-season are going to be our main times for this. Then our resources and time. With these, you need long rest periods. Depending on how far into the season the sessions might be quite short. So we've got to consider all these stuff, as well as the equipment we have, the number of people we have coming in, how many coaches we're working with. And then one of the most important ones at the bottom here is technique proficiency. People need to be really good at movement before we start loading them up or putting them into this sort of physical demand. So then when we sit down, we have our template or a piece of paper in front of us. This is what we're going to work on first. So how many sets are we going to give them? The number of repetitions in each set. The intensity we're going to prescribe for our athlete. This is going to depend on the first two and the adaptation we're looking for. What sort of rest periods are we going to describe? Tempo of the exercise selection, which is particularly important when we consider different power movements. and then the frequency of the sessions. How often are we going to train every week? How does this look over the course of a month or 2 months? Then we've done up an example here of a singular max strength session. So first thing we need to consider before we go in, how are we going to prescribe all of our different variables? So if we look across this table here, this table is taken from your strength module in the S&C. So for our intensity here, we have average percent of 1RM. This is one way we can prescribe intensity. Then we have the rep range that's going to be given. So we're focusing here on the top two here, so our general strength and our max strength. So this is the higher end of that force velocity curve we went through earlier. Then we have our number of sets, our total reps for the session, and then the rest period between sets. So when the focus here is on our max strength and our general strength, here we have our intensity. So we can see they're all very high. The lowest intensity here is 75% of 1RM, up to 90 for general strength, and then 85% up to 100% of our 1 rep max for a maximum strength. In each set, we'd be prescribing between 3 and 6 reps for general strength and 1 to 3 for maximum strength. Then next we have our sets. So for maximum strength, we have 3 to 10 sets, and then for our general strength, we have 3 to 6 sets. And then here's a very important one. To monitor our load for the entire session, we have a total repetitions that we perform. So we have a minimum and a maximum to make sure we're getting enough stimulus that we can cause some sort of adaptation, but not too much that we're going to reduce the quality or overreach in a session. So for maximum strength, we don't want to go over 10 reps, and then for general strength, we don't want to push it past 30 reps in total. So this will be split between our sets and our reps. Then our rest period here is very important. We can see it's quite long here, especially when compared to other types of training modalities down here. So where our maximum strength, we've got really long periods to allow for full recovery, 3 to 5 minutes plus. So here's one of the templates that we use in APEC from our case studies. So we're going to go into just the practical stuff here because we will have covered all the theory in our module. So this is a general strength one. So this is going to be the second row down in that table I've just shown you. So we're going to go through our raise ramp warm up. So we've got our raise section, our activation and mobilization in here together, and then our potentiation. So this is going to be a lower body strength session with the primary movement being a barbell box squat. So in our potentiation, we've got pause goblet squats, and then we've got a barbell squat as well here. So as we work through this, we've got 4 sets prescribed for this session at 4 reps in each set. This leaves us with a total of 16 reps for the session. So this is within our 15 to 30. We've gone for the lower end of the total volume because, as you can see here, each set is prescribed at 90% of 1RM, which is the maximum on the intensity side. So it's a very high load for it. So we've got to try and manage the 3 of these, very important, our load and our intensity. So this is an anterior chain dominant one. So then for our accessory exercises here in our PAA system, we have a posterior exercise. So we have our RDL. And then as well as this, we have a rear foot elevated split squat. So this is a unilateral, so single-sided exercise. It's a similar pattern to our barbell box squat. But in this one, we don't have a box limb in our range of motion, so we're improving our range of motion as well as our single-sided strength with this. For this one, I'm going to show 3 different ways to prescribe intensity. So the first one, we obviously have a percentage of 1RM. This is one way to prescribe intensity. For all exercises, we're not going to have a percentage of 1RM. So for the second, our assistance exercises here, I've done it off an RPE, so a rate of perceived exertion. So we can call this one 7 out of 10. This is a useful measure the more you work with an athlete and you understand how well or how they perceive different exercises when you're prescribing here. Then in our accessory exercises, so this is just a general lower body session. This isn't specific to one case study or one sport. So that for this, I've just included other lower body exercises. So we have some adductor work by our Copenhagen's, calf raises, and then we have some core and proprioception work by including a dead bug. If we had a specific athlete or specific group, so in rugby, say we had the front row or we had the wingers, we could then prescribe real specific stuff. So we might even have individual athletes, we could have some injury stuff, or if it's a certain position that has certain demands, then this is where we could add in different accessory exercises. Included in this as well, other ways of our intensity. So when isometric hold, we just have 15 seconds for each side. And then for the calf raises, the prescription is 3 reps in reserve. Reps in reserve reserve was covered in the hypertrophy webinar by Shane Cahill last time around. So this is another good way to prescribe intensity for exercises which we won't have a 1 rep max value. So then moving into the development of power.
Yep, so looking at a typical power development session. So the first thing you need to consider when prescribing power exercises would be the percentage of 1RM that you're going to use. So here I have a very useful graph to help us prescribe different intensities for different exercises. So on the y-axis here we have peak power, and then on the x-axis we have percentage of 1RM, okay? And then up here you can see the 4 different exercises. So you have a power clean, jump squat, back squat, and hang power clean. So here on the far right in this first box, what we see is you'll generally find that for the power clean and hang power clean, percentage, if you're looking at like 70 to 100% of your 1RM, this is generally where you're going to get the best peak power values, okay, for them particular exercises. So that's going to be the percentage of, or the intensity that you're going to prescribe for these type of exercises, and you're mainly going to be working on the strength speed part of that force velocity curve Alex mentioned earlier. Then moving down from that, what you will find is, so see the little white triangles, so you will find that anywhere between like 30 to 70% of your 1RM, this is the best intensity for prescribing for exercises like the back squat, or even a deadlift where you're trying to perform the exercise very fast and explosively. Whereas anywhere below this, you can see these white triangles here, peak power begins to fall off, and same thing as you start to go higher, peak power output begins to fall off, okay? And then finally on the very left, oh, sorry, that's Alex, will you go back there? Mine's starting to freeze again. And then finally on the very left here, what you can see, so this would be something like a jump squat, and you would look to be prescribing exercise or intensities of anywhere from like 0 to 30%, okay? And this is where you'll have the highest peak power output for that exercise. What you can see is if you follow the line of these black triangles, the higher intensity you begin to prescribe, the lower the peak power output values you see for that. So that's why you want to keep that to a lower intensity as opposed to some of the exercises. So moving on then, if we look at some of the sets and reps and frequency when prescribing for these, so looking at strength speed exercises, so that would be like your Olympic lifts, we're looking for anything between 75 to 90% of your 1RM, depending on whether it's single or multiple efforts. So for a session like this, you're looking at typically 2 to 5 exercises for 1 to 3 or 1 to 5 reps, once again, depending on whether it's multiple efforts, and then for about 3 to 5 sets. So one thing I really want to highlight here is the rest intervals. So you're looking at rest intervals of 2 to 5 minutes. And this is very important because for power training, it's very taxing on the nervous system, so it's very neurological taxing. And the intent of a power session is to perform each rep at as high a peak power output as possible, okay? So unlike a hypertrophy session where you're trying to like just do as many reps as you can, we're looking for quality over quantity here, okay? And then typically you'd be looking to perform like some of these sessions like 2 to 3 times a week. And then looking at some more speed strength stuff, some more plyometric type work, you're looking at lower intensity like I mentioned previously. So anywhere from like 0 to like 30% of your 1RM, and you're looking at maybe 2 to 3 exercises per session. Now, depending on the type of exercise it is, so if you're doing more like repeated jump sort work, or like some fast reactive medicine ball type work, then you could do anywhere from like 10 to 20 reps. But if you're doing like weighted jump squats or that, you're looking at maybe 1 to 3 reps. Once again, you're doing about 3 to 5 sets per session with a long rest between, so 2 to 3 minutes, and you're looking to perform each exercise as fast and explosive as possible, okay? So here on the bottom in this box, I just have a brief example of some of the different exercises that could be performed at each of these sections. So from strength on the left and moving to the right to strength, speed, strength, and then some speed type exercises. So if you just want a quick look over that. Okay, and then moving on. Just 1 second, mine's after freezing. Okay, so when performing a power session, you always need to be considering what is the intent of that session, okay? So thinking back on the force velocity curve, if you look at these images here, I don't want you to get too confused, but on the y-axis now, velocity, you have velocity, whereas we now have force on the x-axis or on the bottom, okay? It's still the same concept as Alex was covering earlier, they're just after changing which axis each is on, okay? But looking at the top right graph here, what you can see is with heavy resistance training, the adaptations we're making to this or to this force velocity curve is we're moving the force aspect of that curve up and to the right, okay? So this means that we're able to produce more force at them slow velocities, okay? Whereas we're not really making much of a change to the velocity aspect of the curve. Then looking at the bottom left, what you can see is this would be the like ballistic, more explosive type exercises, so like plyometric exercises. And what we're trying to do here is we're trying to move once again that curve to the right, but this time it's at those like peak velocities. We're not actually affecting like the high peak force aspect of the curve. And essentially when you combine these two together, we get a mixed response and we're moving that whole curve to the right. And essentially what this means is that we're going to have a more powerful athlete who can exert greater amounts of force at higher velocities, okay? So moving on then. So what would the sample session look like? Well, following a PAA approach, what we could do, what I'd usually program would be, so for the primary lift in this instance, you'd have a power movement, and then the assistance of that would be like a peak force movement, and then you'd have 1 to 2 accessory movements, okay? So looking at the box here, so for the, you'd go to, at first you'd go through general ramp warm-up, and then at the end of that warm-up, I'd add in some maybe force absorption and plyometric type exercises. So here I've programmed in some altitude landings. So that's just stepping off a box and working on landing mechanics and force absorption, okay? And then I'd move on to some box jumps or some sort of plyometric work. And then following that, we'd go into our primary exercise here, which would be a jump squat. So I usually wouldn't put in like Olympic lifts or that in a power session at first, because it requires a lot of you to be very proficient in that movement. And a lot of people don't have the technical capabilities to perform that exercise. So in this instance, I used the jump squat, and that was performed for 3 sets of 5 reps, starting off at like 20% of their 1 RM of back squat, and then you'd gradually increase that up to around 30%, okay? You could even start that off lower at like an unloaded bar, and there are like even like 10 to 15% of their 1 RM. And then following that, I moved on to the assistance exercise, which in this case was a back squat. So we're assisting that first one, and this was performed for 3 sets of 3 reps at a very heavy load, so 85 to 95%. And then my 2 accessory movements here were just an RDL, so that was a moderate force exercise at very low velocity, and then I finished off with a core exercise. So I suppose this looks a lot different than a typical session that people would be used to, but one thing you have to remember is this isn't a hypertrophy session. We're not trying to elicit huge changes to like muscle size. The primary focus of this is power development. So we're thinking quality of the reps over the quantity of work being done, okay? So then moving on. So if I've been working with an athlete for a while and I'm very confident with all their movements, this might be a sample session I'd use, okay? So generally working with a lot of field-based athletes or elite athletes, the majority of the time you'll find they have very good peak force production, so like this blue line here. However, their peak velocity may not be the best, okay? So in this instance, when I'm trying to work on like power output, specifically at those high velocities, I'd use an ascending approach, okay? So I'd start off at the bottom and I'd implement some like reactive strength work. So in this instance, I used assisted jumps or banded jumps. So where you have bands around like your shoulders, or you're holding onto a band and you're doing like 10 repetitive jumps in a row, focused on really short ground contact time, okay? So short, fast jumps. Then following that, I'd move into like a jump squat. So we're gradually moving up this curve. So that's more speed strength. So once again, you're looking at a load of like 0 to 30%, and this is performed for 3 sets of 5 reps, okay? And then finally, we're moving into a power clean. So I was happy with this athlete's technique. So I'd be happy to implement some sort of weightlifting into this. So that's more strength speed. And then finally, we finish on max strength, and that'd be a back squat. So once again, the main goal of the session is to improve power output at those high velocities, so reactive strength. So we're putting them at the start of the session, and then we're working up the curve, okay? So then that's the end of this presentation. But I suppose the 3 main take-home messages we want you to take from this would be, number 1, keep the main goal of the session in mind, okay? So whether it's strength or power development, make sure you know what you're trying to work on and program for that, okay? So for power development, like I mentioned, you don't want to be throwing in like high reps at the end, like finishing off with a circuit type exercise. You want to just prioritize 1 or 2 main outcomes and then focus on that. Number 2 would be the quality of the reps, okay? So prioritize quality and technique and rest periods over quantity, okay? So once again, when performing like strength and power, rest is key. You want to be performing each rep to the best of your ability, so it's more about quality than quantity. And then finally, the last part I would also touch on would be your understanding. So to be a good coaches generally have a really good understanding of the adaptations they're trying to elicit. So this comes back to your anatomy and physiology again. So it's easy for someone to look up a sample session of like a sample power session or a sample strength training session, okay? It's a lot harder for the coach to understand why they're implementing that and the changes they're trying to elicit, okay? So this is something I think a lot of coaches can neglect sometimes, but it's very important. You need to have a really good standing of your physiology and the adaptations you're trying to elicit when implementing an exercise program, okay? So moving on, so that's the end of the presentation now.
That was excellent, Craig. If anybody has any questions, feel free to just throw them into the live Q&A section, and myself and Craig will answer them. Or even if you just want us to further elaborate or go through something we've already gone through again, that's no bother. We can just do it now. So feel free, just throw them in. For a start, Craig, one question is just how would you measure power output in one of your athletes?
So like I mentioned earlier, so when you're programming for power, a lot of it's based off just your 1RM, so your max strength. However, if you want to have like a good understanding of, or if you want to be able to compare peak power output between athletes, one good way of doing that would be like looking at jump height, okay? So you could measure jump height. So there's a number of ways to measure jump height. So you could use like a force plate, you could use like a stand and reach, or there's even some apps now that measure it. Another good way to use it is if you have access to the equipment would be VBT, or velocity based training. So that's basically, it's a little device you can attach to the bar, and from there it tracks the speed of the bar as you're performing the exercise. And then finally, what you could also use would be like an isometric mid-thigh pull. However, this is quite costly and you only generally find it in like physiology labs. And what this does basically is it measures the rate of force development, so the athlete's rate of force development, so how fast they can produce force. But there would be like 3 main ways of looking at it. But definitely, I think CMJ is a very cost-effective way of figuring out someone's or measuring power output for an athlete.
Thanks, that's really good. I just include as well, just from myself, when I was pointing out earlier the different considerations for when athletes and doing strength and power, these are involved in the testing as well. So depending what test we're going to use in our athlete, we also need to consider the level, the training age, time of season, etc. So for example, a lot of our stuff for the power and for the strength was prescribed off 1 rep max, but we don't necessarily need to do a 1 rep max test each time. So there's other ways we can calculate that. So we might include a 3 rep max, a 5 rep max. There's different conversions tables which tend to be quite good and quite accurate for using this. There's quite a few of them. They're easily available online so that you can work out what your 1 rep max is and use this number to prescribe your intensities for your sessions without having to go through a 1 rep max session. So 1 rep max testing session is quite taxing on the body. It also requires a good amount of movement proficiency and technical proficiency because it can be dangerous trying to push to the very end, especially if they're going to go what will be slightly over and they might miss that lift. It can be very dangerous then, especially with something like a bench press.
Yeah, I think you make a really good point there, Alex. It's like unless you're a powerlifter looking to compete, where you have to be able to like perform 1 repetition maximums, I don't think there's any need to put athletes through that. Okay, it's just increasing the risk of injury, where something like a 3 RM is you're still bringing them to failure, but it doesn't require as much technical proficiency, like you said, and they're less likely to get injured due to like loading them like to their 1 RM. So I think for most people looking to figure out a client's like 1 RM, using a 3 or 5 RM and then using the conversion table is a much better option.
Yeah, there's a huge amount of stuff you can cover in relation to strength and power. And if you have any questions, you can still fire them in. We'll just keep chatting for a bit. Another one, just while we're on the testing, is that if you're working with certain athletes, you can test at different points of the curve. So when we're talking about our 1 rep max, this is always the max strength at the very top of the curve. But if this isn't always our main goal, there's other tests we can do. So we don't necessarily always have to do it on bench, squat, or deadlift. So we can do our testing again on, say, jumps. So we can measure our jumps at the start of our program and at the end, and then we're testing further down their reactive strength. Or we could also do speed testing. So if we have set speed gates, you could do your outright speed testing and see how this changes from the start of your session to the end of the session. So just, you need your athletes to, especially in sports, they need to work across the curve, so they can also be tested across the curve, because testing helps us to monitor our progress and check in on our athlete and how we're going, how our program is working. Okay, so I don't think we've got any more questions coming in. So I'd just like to say a big thank you to Michal today for being our moderator and organising this. And then a huge thanks to Craig as well. He did excellent work. Big thanks and really well done. And then just for all the students, this webinar is going to go up on the blog, so you still have access to this and you have access to all our future webinars. So if you fill out the survey or if you ever have any requests for stuff you'd like us to cover more, as an APEC student, you can always come back and revisit these webinars and catch up on the blog and other things. So always keep in contact with us and let us know if you need anything else.
Yeah, and just before we go, sorry, Alex.
Yeah.
Just before we go there, so us as an APEC team, so as everyone's probably aware of, the Olympics is going on this weekend, and APEC have decided that we're doing like a mini Olympic series on Instagram. So if you all go on to the IGTV series and follow along, and we're going to be covering like different events throughout, and we're going to be talking through like the physical demands or the needs of that particular sport, and then talk about like how the athletes might have been preparing for it with regards to training wise, nutrition wise, training monitoring, and then also we'll be covering injuries, so why athletes might get injured or common injuries within that sport. So feel free to follow along. There's already 2 or 3 videos up there, so feel free to go and have a look. And yeah.
Perfect. Thanks very much.
Thanks everyone.
you.